Parasympathetic nervous system is also known as the rest and digest system or the craniosacral division. The term craniosacral is a little bit outdated, but it's an anatomical description or name, and it indicates that the parasympathetic nervous system uses cranial nerves and nerves that arise from the sacral plexus as routes of output to target organs. What's nice about the parasympathetic nervous division is that both neurons are cholinergic, and both neurons secrete only acetylcholine, period. There are four cranial nerves that are used by the parasympathetic nervous system, and they innervate pretty much glands that are in your face and your head. This would include your salivary glands and things like your lacrimal or tear glands. The four cranial nerves are cranial nerves 3, 7, 9, and 10. The vagus nerve here, oh, and I encourage you to stop this video and see if you can name 3, 7, 9, and 10. The vagus nerve, which is number 10, is the exception here because it innervates digestive tract organs rather than target organs in the head and neck. However, it mostly innervates glands and it encourages secretions, much like the tear ducts and salivary glands do. In the craniosacral division or the parasympathetic nervous division, all of the preganglionic fibers that originate and travel through the cranial nerves, they all synapse with their postganglionic fibers in a collateral ganglion, and then it's the postganglionic fiber that then travels to the target organ. These collateral ganglia, these are what make neck surgery such a disaster and neck surgeons kind of close to like gods. The postganglionic fibers that emerge from these collateral ganglia, they then travel to the target organ, kind of like how I have pictured here on the heart. Most of the time, it's not one postganglionic neuron, but many postganglionic neurons that arise from one preganglionic neuron. The postganglionic neuron has nicotinic receptors in its cell body. And these nicotinic receptors allow it to generate action potentials when connected with acetylcholine. Therefore, the preganglionic neuron is exciting the postganglionic neuron with acetylcholine. The postganglionic neuron, it then releases its own acetylcholine because it's a cholinergic neuron. However, this time, the acetylcholine that the postganglionic neuron releases, it connects with muscarinic receptors that are on the target organ. Muscarinic receptors can be both excitatory and inhibitory. It depends more on the organ than it does upon the receptor in this case. The sacral division of the parasympathetic division leaves the spinal cord using nerves that arise from spinal levels to S2, S3, and S4. Once these nerves leave the spinal cord, they travel through the ventral root, the spinal nerve, the ventral ramus, and then they become nerves that are called splanchnic nerves. These are specifically called the splanchnic pelvic or pelvic splanchnic nerves. And here they are right there. These specifically are pelvic nerves and arise from the sacral section of your spinal cord. So these pelvic splanchnic nerves innervate your colon, your anus, your bladder, and your choice of reproductive organs. As these are parasympathetic fibers, they are connected with activating these organs. The preganglionic fibers, that arise from the sacral section of your spinal cord form those pelvic splanchnic nerves. And this right here would be one of the pelvic splanchnic nerves. Such a funny word. These nerves, the preganglionic neurons, they enter the target organ and they release acetylcholine. That's what you're seeing here, acetylcholine. The postganglionic neuron is embedded completely within the target organ, and it has nicotinic receptors in its cell body that allow it to respond to acetylcholine and become excited. In turn, it releases its own acetylcholine, but this acetylcholine now connects with muscarinic receptors on the smooth muscle of the target organ. And these can cause either inhibition or excitation. In this example here with the bladder, which we're trying to get the bladder to contract in an effort to urinate, which is a parasympathetic response. I know that seems funny. I want to excite my bladder to rest and digest, but rest and digest is not being dead. Rest and digest is using your organs and exciting them. Drugs that treat overactive bladder, like Detrol, they sit on and block these muscarinic receptors embedded in the bladder muscle, which is called the detrusor muscle. By blocking these muscarinic receptors, it prevents the bladder from contracting or being overactive. There are other drugs that also prevent the nicotinic receptors that are on the postganglionic fiber. All of these drugs, they are called anticholinergic drugs because they are anti or prevent the connection of acetylcholine to its receptors.